Hi there, and welcome to another edition of Mr. Douglas's Math Lessons. Okay, today we're going to venture into the land of Azeroth, where we will be looking at the battle of orcs and humans in, dare I say, a radical way. Yes, we're going to explore how to simplify radicals. So, let's get to it, shall we? Okay. Well, there's some exciting stuff that you're going to notice is that my sound should be sounding better now. I've got an actual microphone that I'm recording with. So hopefully this lesson will sound a little bit better to you, and we'll see how this kind of goes. We're talking about radicals today, so it's going to be a rad lesson. We're in the land of Azeroth and WoW, and yes, I am a Warcraft player. I like being a tank. For those of you who are wondering, and if you don't know what that is, that's completely okay. It has nothing to do with math. What we're going to be talking about today are radicals. So we're talking about this thing right here, and we're going to find out what everything is called first. So this entire thing is going to be called a radical. So you've probably seen something with radicals a little bit. And you're going to have numbers here, like a 16, and you must know what that is, and we call that the radicand. And then, of course, you also have the index. So the index is, let's use a different color for the index. The index is right here, and this tells you what kind of radical it is. And one thing that you'll notice is that we don't always put the 2 there. The 2 is a given. So if you see a radical, like a square root, and let's say it was like, what's the square root of 49? And most kids, they see this and they go, oh, okay, it's going to be 7. But then they realize actually it should be plus or minus 7. We'll get to that into that in a little bit. But we know that we're talking about square roots. We don't actually write down the 2 there. So it's a given. So if something isn't there, do realize that. Now, you can have different kinds of roots. A really popular one are cube roots. So if the cube root of 8, for instance, is 2, so you might be wondering, like, so what does that actually mean? Well, that's a great question. So what does it actually mean? Well, if we're talking about the square root of a number, so if we're looking at the square root of something, and there we go. So the square root, let's go back to the square root of 49. Remember, there's a little 2 there. I want to know what number times itself twice, that's why the 2 is there, gives you 49. And of course, you're thinking like, well, 7 times 7 does, that gives me 49. But we also have to remember that negative 7 times negative 7 also gives us 49. So that's why we're saying it's plus or minus 7. Now, for the most part, we always go with a positive answer of it. But it's important to realize, though, that there are 2 different versions. And when we're talking about cube roots, so we're talking about the cube root, it means what number times itself 3 times would give yourself the answer of 8. And if you're thinking really hard on that one, if you went 2 times 2 times 2, that would give you 8. Notice that we're not saying plus or minus 2 as well. So do kind of realize that a little bit. So that's kind of an interesting thing there. So you know some of the parts. There's the index, the radicand, the radical. Today we're going to talk about simplifying radicals. So simplifying. So we're taking a step up, and we, just like with fractions, so remember back in probably, I don't know, maybe grade 6, maybe grade 5, if you had 10 over 12, your teacher would say, you must simplify. And to simplify that one, you basically had to divide by 2, and you divide by 2, and you end up getting, what was that, 5/6. And you're like, yay, I simplified, I'm happy. And now, you're probably in middle school, high school, your teacher doesn't tell you to simplify because it's a given. It's like breathing. Right now, you're breathing. Were you thinking that you were breathing? No, you're just doing it. It's automatic. So simplifying should be automatic. And that goes for the exact same thing for simplifying radicals. So let's take a look at what simplifying radicals just might look like. So let's get a radical here. Let's get my favorite example of simplifying is square root of 20. Square root of 20 is awesome. So you ask yourself, are there any two numbers that multiply to give you 20? Heck no, there certainly aren't. So to simplify, it's kind of fun. You need to think. So you need to think of two numbers that multiply to 20. So that multiply to 20 where one is a perfect square. So that's the key. You must think of two numbers that multiply together where one is a perfect square. So what are perfect square numbers? Ooh, I'm glad you asked. So 1, 4, 9, 16, 25, 36, ... And how did those become perfect square numbers? I'm glad you asked that. Well, you might have realized that 1 is simply 1 squared. 4 is 2 squared. 3 squared. Do you see a pattern? I see a pattern. So these are all perfect squares. So can you think of two numbers that multiply to give you 20, where one of those numbers is a perfect square, one of these numbers? So if you think of all the ways that you could multiply to give yourself 20, there would be 1 times 20. There would be 2 times 10. 4 times 5. And I think that's it. And when you're looking at it, you're saying, okay, well, I need one where there's a perfect square. So that cancels out this one. Can't be that one. Well, 1 and 4 work. You always want to go with the biggest possible square. So 4 and 5 are our winners. So we can say the square root of 4 times the square root of 5 gives us the square root of 20. We'll talk about why that is in a second. What's the square root of 4? Well, the square root of 4 is 2. And the square root of 5 is nothing. So your answer, your simplified version of the square root of 20, is 2 root 5. Now let's take a look at why that is. So there's a law, and you're going to get lots of laws when talking about radicals. There's a nice little cool law that says the square root of any number can be expressed. So the square root of, let's say, xy can be expressed as the square root of x times the square root of y. So that just basically says if I multiply two numbers together with the radicals, that they just become one like that. So if we go back to our example of the square root of 20, so we have the square root of 20, and I said I wanted to know two numbers that multiply. Well, we're going to follow this law and get that. The reason you want a square number is because you can actually do something with the square number. The square root of 4 is 2. We know that. The square root of 5 is simply the square root of 5. So we just leave it like that. So that is where it kind of comes from. Hopefully that makes a little bit of sense. And let's go and take a look at what that might look like for a couple other questions now. So let's get rid of that one, and let's go and get, let's go with green, because I'm liking green a little bit. Let's go with what is the simplified version of the square root of 40? Okay, so what two numbers multiply to give you 40, where one is a perfect square? And I love always kind of splitting my numbers up like that. And then I'm left with 2 root 10. That's my final answer. And you actually that's how you say it, 2 root 10. 2 root 10 is how you would go and say that one. Now you might have, what's a really good one? Oh, I'll show you a really good one. This one always gets kids. The square root of 48. The square root of 48. So if you're a typical student, and you're like, okay, I know I need to get two numbers. And the first thing you always think of, almost every single kid thinks of, is 4 root and 12. They think 4 times 12 is 48. They go, great, my answer is 2 root 12. And they're like, yes, this is going to be awesome. But then they get back their test or their quiz, and they have something that says half mark because you need to simplify it further. And they're like, oh no, but I thought I had it right. Does this follow our rules? It absolutely does. Good job. But is 4 times 12 the biggest number you possibly could do to get to 48, where 1 is a perfect square? It's unfortunately not. The biggest one is actually 16 times 3. So if you did 16 and 3, you would get the final answer of 4 root 3, which is the correct answer. That will get you the gold star in your test. But fear not. If you're a student who went 4 and 12, that's okay. You just need to always ask yourself, before you kind of submit your test or finish your homework, is there anything more that you could do to root 12? Well, there certainly is. I know that 4 times 3 will give me 12. So now, look at what we're getting. We're getting 2 times root 4 times root 3. So this becomes 2 times 2 times root 3, which is, dun 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 dun, 4 root 3. So make sure you're simplifying all the way down when talking about those kinds of square roots. Now we talked about square roots. There's also cube roots. So cube roots work the exact same way. And we'll start off with the nice easy one of the cube root of 8. So what number times itself 3 times will give you 8. And hopefully you know that that would be just 2. So it's important to know the cube numbers. So remember how we got cube numbers and square numbers is we just kind of follow these ones. And honestly, you probably only need to know the first 10 or so. It'd be really worthwhile to memorize these. Well, 1 is also a cube number. We have 8, and then we got 27, and then it becomes extremely hard for me. I think we go 64, and then 125, and then it gets really, really big. I think it becomes 256. I could be wrong, but I think it's 256 next. So know some of these numbers. So it becomes very, very easy for you to know those. So know those, record them down, memorize them. Let's extend just a little bit, and let's take a look at some trickier situations. And let's just maybe even take a step back and talking about the opposite of square rooting. So the opposite of taking the square root of something is, of course, squaring something. It's kind of like the plus is to minus, as minus is to plus, or multiplying is dividing, as dividing is to multiplying. So let's take a look at what happens when you go the opposite way. So let's say you had this, the square root of 5 squared. So what does that really mean now? Well, you know when you square something, you times it by itself. So this really means the square root of 5 times the square root of 5. If you go back to that law, remember that law that we talked about? This just means the square root of 5 times 5. Well, what's the square root of 5 times 5? The square root of 25. Well, what's the square root of 25? It's just 5. So an easier way to kind of think about it is if you square a square root, it gets rid of the square root, leaving you just with the radicand, just with the 5 there. So this is a long, complicated way. I would never expect a student to show this as they're working. But it's good to know of how this kind of goes. Most students kind of just memorize that if I square a square root, the square root just disappears. So there's a little introduction to radicals and square roots and different parts. And I can't emphasize enough that you really do want to memorize your square numbers. So know your square numbers. and you really want to know your cube numbers. And you can look those up on this thing called Google. You might have heard of it. It's pretty cool. They get lots of good stuff there. And it will help you become just more versed in these things, because basically you'll be using all of these for all of your square root work. So know those. There we go. All right. The Battle of Azeroth continues in this radical math lesson. So to step it up a little bit, we are going to look at radicals that have an index other than 2. So as you know, a typical radical question is looking at square roots. And the index is actually a little 2 that you don't usually see. So what happens if it's not 2? If it's 4, or 3, or maybe even 12? Let's take a look in the challenge section. So what's going to be a challenging radical question? Well, a quick review is, in case you kind of jumped over to the challenging stuff, is just so we're all talking on the same sort of things, is that we have all of these parts just so we know that we're saying the same kind of language. Actually, let's put a letter there. Let's make it X like that. And so we know that we're talking about this would be called your index, and the A here is called your radicand, and the entire thing, of course, is called your radical, just to make sure that we didn't forget that. Okay, well, what we're going to be talking about is some different laws. So we briefly mentioned one of the laws in the last little segment, but we're going to look at some laws that we're going to be using in all of the lessons that you'll be seeing about radicals. So let's take a look at the laws, shall we? And I'm just going to write them down, just like the really old person in ancient Greek probably figured everything out. And the very first one is, we're going to say, is for any radical, kind of like this, we can actually make this to an exponent that's a fractional exponent. This is a to the m over n. So hear that again. So this is a to the power of m over n. And remember that if you don't see a number here for the radical, the number by default is 2. And if you don't see a number here by default, the number is 1. So we're going to play around with that law a little bit. The other law is we're going to take a look at is this one right here. And we talked about this already. So if you have the square root, and we can simplify this as just simply being the square root of a times the square root of b. And that will give you the square root of ab. A couple other ones that we'll just have this written down is if you have the square root of a over b, we can rewrite this as the square root of a all over the square root of b. And this becomes lots of fun when we start to simplify things. So that's a fun rule to know. And the last one that I'll try and squeeze in on the way over here is it's just rewriting things when we're talking about moving things with perhaps brackets. So if I had to rewrite this one, and I wanted to make it to a power, I'm going to try and squeeze this in here. Whoop. And this might seem kind of obvious. Whoop, to the m. There we go. So the square root of a to the m power is kind of how that would work and stuff. And I'll give you a bonus one. I'll give you one more bonus one. Like, wow, there's so many different things. It's a double square root. This is kind of cool. Only math teachers say that. This is going to be really cool, guys. This is going to be awesome. So these are two different kinds of radicals. So this would be really, really cool. So this is to the mn root a. So to get the index, you actually would multiply both indexes together to get one index of a. That looks pretty fun. Let's go take a look at some questions and see how these go. What color should I go with? We'll go with orange. I'm feeling kind of pumpkin-y today. And let's start with, where do we want to start? Let's take a look at, well, actually, let's take a step back. Let's go with some exponent laws. If we had x to the 4th times x to the 5th, our exponent laws say this is x to the 4 plus 5. So our final answer is x to the 9th. Okay, so the common kid mistake is to think this is x to the 20th. It is not. It is x to the 9th. So we're going to use that a little bit, and now we're going to combine this idea with this. Let's say we had the square root of x cubed. So the square root of x cubed. Okay. Well, you're thinking, how can I take the square root of a variable? Well, you really can't, but we can simplify this. So remember the simplifying law is that we said the square root of a times the square root of b is equal to the square root of ab, right? So can we change this where one of a or b is a square number? A square number, but it's a variable. Exactly. So what does a variable look like when it's squared? Well, variable look like when it's squared? It looks like that. Is the x squared? Sure is. Is the x a square number? It is now. And could we multiply x squared by something to get x to the cubed? Sure, if we multiplied this by just x. Remember, there's a little 1 there. So if I multiplied x squared times x, would I get x cubed? I would. So these are equivalent. And what's the square root of x squared? It's x. And we still have the square root of x. So we write this x root x. That's how I would say it. So if I was going to simplify this, I'd think of two numbers that multiply to give me a square to the power of 3, where 1 is a square number. And then I would have x root x, like that. So let that sink in for a little bit. Let's go with the next one. And let's kick it up another notch, just a little bit. So let's take a look at something that has some different kind of combinations. Let's go with 20 x to the 5th. Okay, first deal with the 20. What two numbers can multiply to give you 20, where 1 is a square number? And hopefully you're saying, well, the square root of 4 and the square root of 5. And can I think of numbers where there's a nice square number here? And I can tell you a little hint, but this is going to seem kind of a little bit weird. But it would be x to the 4th times just x. Now you're saying, that's kind of interesting. You basically want to, this is the kind of the rule, this is the unofficial rule that I always kind of teach kids. Just take this and divide it by 2. And you get, remember back in the days, you have 2 remainder 1, right? So this, just divide it by 2, and eventually that means 2 x's go on the outside and 1 x remains on the inside. You'll see what I mean in a second. So taking this, the square root of x to the 4th is, you just divide it by 2. So what is that? It's just x squared. And can you divide this 1 by 2? Not really. So you're just going to be left with that x staying there. What's the square root of 4? That's 2. And can you take the square root of 5? Nope. So your final answer is 2x squared root 5x. Oof, that's a good one. Let's take a look at another one. Let's take a look at the, I love this lime color, the square root of 16 x to the 4th y to the 7th. Okay. Well, the square root of 16 is just going to be 4. What's the square root of x to the 4th? It's just x squared. And this 7, I'm going to divide it by 2, which gives me 3 remainder 1. And that 3 y's will go on the outside. So my final answer would be 4x squared y cubed, those are those three y's, root y. Okay. Well, let's even take that one just a little bit further. Let's switch it up just a little bit. And I'll give you another example. We'll stay in the purple. And this is the square root of 16 to the power of 4. Ooh. And y to the power of 7. Very similar. But I'm actually saying the square root of 16 to the 4th. Okay. Well, I'm going to do a little trick here. So I wanted to show you this trick. This trick is pretty neat. So here's the trick. I'm going to turn this stuff into a square. So I'm going to turn this into something squared. So I'm going to turn this into 4x squared y to the 3rd. And I still need another y on the outside. So all I've done is kind of change this to where one of them is a square. And I want to do that because it goes back to that same idea, is the square root of anything squared is itself. So I've made this into a square. So the square root of this square is just itself. It's just this stuff, like that. So what's my final answer going to be? It's going to be 4x squared y cubed root, make that a nice little 2, root y, like that. So I wanted to show you that kind of little trick because it becomes very, very helpful. Let's take a look at another idea. And this is going to be about reducing the index. So this is another simplifying thing. So we're going to call this reducing the index. And we're going to use the law. So we're focusing on a few laws today. And this law, is a to the m over n. That's really important to kind of understand that. So let's start off nice and easy. Let's take a look at this. So it's an index of 4. And we're going to have to the 64th, like this. So a couple things is I'm going to go and actually change 64 so it has a base of 2. What do I mean? I want to say, if I have a base of 2, what could I put that to the power of to make this not 64 anymore? So 2 to the power of 6 is 64. And I want to do this for a pretty fun reason, is using this idea here. So this will now become the, how would I do that? I would have 2 to the power of 6 over 4 to 6/4, which of course is, if I simplify it, just like a regular fraction law, is 2 to the 3/2. And you know that this number tells you what kind of radical thing it's going to be. So if it's a 2, it's a typical old square root. Oh, it's just a regular square root. So now I'm going to go down here. So this is like square root. Remember the 2 goes there. So it's just a square root of 2 to the power of 3. And of course, 2 to the power of 3 is what? Well, 2 to the power of 3 is just 8. So this is, what's this? The square root of 8, which using our other square root stuff is just simply 2 root 2. If I was going to go and simplify that. So this all came all the way down from here to there. Now one thing, so if you're looking at this screen, you're going like, wow, okay, I can follow along. But why did you do, so if I'm a student, I'm going to say, why did you change 64 to 2? And how would I know to do that? How would I know? Well, part of it is getting more experience, just getting exposure to these kinds of things. But if you put a 1 here, because this is 64 to the 1st, right? And if we follow our little laws here, and that would just be 64 to the power of 1/4. and you can punch these into your calculator and see what happens. But that wouldn't really help you too much. So you want to try and get things down till you get a base of 2. That's what you want to be doing. So you want to have these numbers, these kinds of things here, be able to simplify. So you eventually get down to fun things like this. So square roots or cube roots, to start playing with it a little bit. So it's a lot of number sense, a lot of playing, and just trying things out and being open to that is really, really important. Let's see another one. Now, definitely as a professed math geek, I love these kinds of things because it's like a puzzle. I do see it as a puzzle. And you don't really walk around that much trying to find, index laws of 16. I know that. But it definitely does challenge your number sense. So here we go. And you're like, where would I start with this one? Well, again, can you make something become maybe a square? Could you do that? Maybe a little bit. Use that little trick that we had. So let's say I did want to make this into a square. And the reason that I want to do that is because I know I'm going to get a really cool thing of happening with the 2 and the 6. Okay, this is going to work out really nicely. So could I do something here to put in here to make it a square? Sure. I could go and make this 4, because 4 squared is 16. And then this would be x to the cubed, because 3 times 2 is going to give 6. Remember, this is 3 squared. So you multiply them together there. So I'm going to do that. And why am I doing that? Well, let's just follow this out, see how this plays out. Let's go and keep this in our bracket, so 4x cubed. And what does this and this now become? This can become 2 over 6. So 4x cubed to the power of 2/6. Okay, so if I'm going to go and kind of do all my math stuff there, this 2/6 is going to simplify to 1/3. So 4x to the third to the power of 1/3. And if we do that, then we know we're dealing with a cube root. Okay, just follow my logic here. So now we're dealing with cube roots of 4x to the third. This is like saying, what's the cube root of 4 times the cube root of x to the third? Well, the cube root of anything to the third power is just itself. Cool. So your final answer for this one is x cube root 4. Boom. Done. I'm even going to put a really interesting little blue box around there. So that is really challenging your number sense. And again, being able to play with it and to think about how can I make my indexes be some kind of fraction that will simplify to give me a cube root or a square root. Great job today. Let's wrap it all up.
Well done, everybody. You have had a radical time, hopefully. So, hopefully you've learned a little bit about how to simplify radicals and the different parts of radicals as well in the challenge section, and you should be good to go for some of your basic simplifying questions. Until next time.